This video looks at interpretation of Tukey HSD post-hoc test results. In the fitness study, researchers found a significant difference in mean fitness by instructional method. To determine which mean differences are statistically significant, post-hoc multiple comparisons must be used. Because all of the assumptions for the ANOVA were met, and the sample sizes were equal, the researcher would use the Tukey HSD post-hoc procedure. Here are the results of this analysis. This table indicates no statistically significant difference between the bootcamp and control methods, but all other mean pairs were significantly different. Mean fitness for the Harvard instructional method is significantly higher than all other groups, so the researchers would recommend that the school system adopt this method for its physical education classes. Let's look at how the researchers came to this conclusion. They selected Tukey from the list of multiple comparison tests available in SPSS, which produced this table. The table shows comparisons of all mean pairs. The program listed in this column is compared to the program in this column. The mean difference for the pair is shown in this column. Each comparison shows up twice. It's redundant, but it also allows you to decide whether you want to compare control to bootcamp or bootcamp to control, whether you want to interpret a positive or negative mean difference. Multiple comparisons can be done as hypothesis tests or estimation procedures. SPSS provides both. Sticking with the control versus bootcamp comparison, these means are not significantly different. Sig is the p-value, which is greater than 0.05. And when the null hypothesis is not rejected, the confidence interval will always include 0. The standard error is based on the within groups mean squares. Because the sample size is the same for all groups, this value is the same for all mean comparisons. Let's take a closer look at how the Tukey HSD procedure works. First, a value for the honestly significant difference is calculated. The HSD is the critical value of the test statistic for hypothesis testing. If the absolute value of the mean difference exceeds the HSD, we reject the null hypothesis that the two population means are equal. For estimation, a confidence interval is constructed by subtracting the HSD from the mean difference for the lower bound and adding it to the mean difference for the upper bound. SPSS doesn't report the value for HSD. To find it, we look at the mean difference and the confidence interval. We can either subtract the lower bound of the confidence interval from the mean difference, or subtract the mean difference from the upper bound. Both methods produce the HSD value. First, let's subtract the lower bound of the interval from the mean difference. For the control versus bootcamp comparison, the mean difference is 11.5. and the lower bound of the confidence interval is minus 3.64. The HSD is therefore 15.14. If we subtract the mean difference from the upper bound, we get the same result. The HSD is the critical value of the test statistic for the hypotheses involving each mean pair. Any absolute mean difference that exceeds this value leads to rejection of the null hypothesis that the two population means are equal, as indicated here, and here, and here. Looking at the confidence interval side, these intervals are constructed by subtracting the HSD from the mean difference for the lower bound and adding the HSD to the mean difference for the upper bound. And any mean difference that is statistically significant will also produce a confidence interval that does not include 0. We could also look at the positive values, which are often easier to interpret. Note that the confidence intervals just flip from negative lower and upper bounds to positive. Remembering that each comparison appears twice in this table helps diminish the intimidation factor when you look at it. In addition to the multiple comparison table, the Tukey procedure also produces a table of homogeneous subsets. This table focuses on groups that are similar. Means that do not differ, such as bootcamp and control, will appear in the same column. Coaching and Harvard appear by themselves, indicating that they are significantly different from all other groups. This p-value at the bottom of the column is the value from the multiple comparison table for this mean pair. These are the p-values for the difference between all means in these columns. Since there is only one mean in the last two columns, the p-values are both equal to 1. The bottom of this table will always tell you that a harmonic mean sample size was used. If the sample sizes are equal, this footnote can be ignored. However, if the sample sizes are not equal, results from this table and the multiple comparison table may not match. When this is the case, the multiple comparison table is more accurate, and the homogeneous subsets results should not be interpreted. The table reporting the multiple comparison results is taken straight from the table of homogeneous subgroups. When you write up these results, be sure to account for all mean pair comparisons. Here's how these results might be summarized. First, indicate the procedure that was used. The mean fitness for Harvard was significantly higher than all other groups, and coaching was significantly higher than either boot camp or control. There was no difference between boot camp and control methods. Based on these results, the researchers would recommend the Harvard instructional method for 8th graders taking physical education classes.